Hello friends, welcome to my channel. Let's have a look at a recent problem, problem 2410, maximum matching of players with trainers. In this video, we're going to share two formats of solutions. Essentially, they are the same solution. So one is based on the two-pointer trick, and the other is based on heap simulation. So first, let's roughly look at the problem statement, and then we do a simple analysis, and finally we write the code. We are given a zero-indexed integer array players, where players I represents the ability of the ith player, and we are also given another zero-indexed integer array called trainers, where trainers J represents the training capacity of J's trainer. So the ith player can match with the J's trainer if the player's ability is less than or equal to the trainer's training capacity. Additionally, the ith player can be matched with at most one trainer, and the J's trainer can be matched with at most one player. So we are required to return the maximum number of matchings between players and trainers that satisfy these conditions. So here are two examples. So in example 1, so the matchings are 2. So in the explanation, so it represents a V. And in example 2, so because we have only one trainer, so the matching is 1 because this trainer has a larger capacity. So the constraints on this problem are the following. First, the length of the two lists are bounded above by 10 to the power 5. So this defines the problem size. And they are also bounded below by 1. So it means that both of them are not empty. So the second one is actually on the elements range in the two lists, so which is not negative and bounded above by 10 to the power 9. So with that said, we are ready to do the simple analysis here. So here, due to the problem requirement, actually we can sort both the players and the trainers ascendingly, and then we can compare the players and the trainer. So the idea is that, or the condition is that, if the player less than or equal to trainer in ability or capacity, so we match them, and then we look at next pair of player and trainer. Otherwise, it means that the player is larger than trainer in ability or capacity. We're going to try to find next trainer to match the current player. So that's actually exactly a two-pointer method or idea or procedure. So the above idea can be realized using two-pointer trick or use heap simulation. As such, we are going to present two formats of solutions based on the same idea. So first, I'm going to use a two-pointer trick to do the implementation, and then we're going to use a heap, do a simulation just as a practice. So with that said, let's first look at the first version. So here I'm going to use two-pointer trick. So for this, first I'm going to sort the players and trainers in place. So this sorting step is actually very important for this problem logic. And then we're going to get the length of players, the length of trainers, and then we are ready to do the for loop for the two-pointer. So let's say ij equals 0, and then we are going to initialize a result variable which is going to hold the contents, and then we are going to do iteration while I less than m and, so here the logic is add, and j is less than n. Then we're going to check if players I is less than or equal to trainers J. If so, there is a match, so we're going to increment the result by 1, and then look at the next. So looking at the next pair of player and trainer correspond to increment I by 1 and simultaneous j by 1. So this is one case. Another case is that the player's I is strictly larger than trainer's I, so we cannot match the current trainer with the player. So we are going to look at next trainer, so corresponding to increment j by 1. So thus we exit this while loop, we finished the pairings. So we're going to return the final state of the result. So this is the format of solution. Let's first do a special case check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So now let's do some slightly modification to present another format. So another format basically is a simulation. So we're going to call this version V1. And now in this version, we're going to practice the heap data structure. So essentially the same thing, but so we do not need to explicitly do the sorting now. So let's see. First, we're going to make heaps out of players or trainers. So let's see, heap q, heapify. So players, heap q, heapify. So trainers. So this is in parallel to the two thoughts in the above solution. So next, so we're going to initialize a result variable, right, to do the counting, and then we are going to write a piece of code parallel to the while loop above. So here players and trainers. If both of them are not empty, then we can consider the smallest element in both of the two heaps. So that is, if players 0, so always at the root. See, if it's less than trainers 0. So in this case, we compare this player and the trainer. So we're going to increment this result by 1. So pairing them corresponds to pop this pair of player and trainers out of the corresponding heaps. So we're going to do heap pop. So we're going to pop players, and then we're going to heap pop trainers. So this two pop operations actually correspond to here I plus 1, j plus 1. Otherwise, so the current trainer cannot train the current player. So we are going to look at the next trainer. So this corresponds to pop the trainer. So this corresponds to j plus 1. So next we're going to return the result. So this is another format of solution. So let's do a check directly. So here, yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the cases. Yeah, that's about it for this specific problem. And in this video, we presented two formats of solutions. So one is based on the two-pointer trick, and the other is based on the simulation using a min heap. So with that said, I guess that's it for this video. Thank you.